Hey everyone, it's Coach Fred, and today I'm going to be talking about something with quadratic functions that you've actually been using, but I want to go into more detail as to where the equations come from, called vertical motion problems. And we're going to use our calculator as well as by hand, find different information regarding these types of problems. But to start, what I'd ask you to do is we have now learned every method to solve a quadratic equation. We've graphed with our calculator, we've done factoring, we've done the square root method, we've completed the square, the quadratic formula, and we actually have also guessed and checked. So I'd like you to, in your own words, come up with when is the best time to use it and what an advantage of using the method might be. Now this is really up to you, but we're going to talk about it in class tomorrow, and I thought that might be a good place to start. Okay, so what is vertical motion? Well, anytime an object is thrown in the air or dropped off a height, we call those vertical motion problems, okay? And they actually come from a model that uses gravity. But basically, we use this model. There's two of them, and there's two of them because you're either going to be given the information in feet per second or meters per second. But the formulas that we're going to use are negative 16 t squared plus v sub 0 t plus h sub 0. So negative 16 is a constant. It's not going to change, and that actually comes from gravity, because I think the actual formula is negative 1/2 32 feet per second, because I think that is the speed of gravity in feet per second. So when you simplify that, it becomes negative 16. So negative 16 t squared plus v sub 0 t. So v sub 0, I've given to you and you just didn't realize it. That's actually the initial velocity of the object in feet per second. And h sub 0 is the initial height in feet per second. And we know that to be the y-intercept. So every time we've graphed it, we've pointed out that was the starting amount. That's actually the initial height, okay? So think of the initial velocity as maybe how hard you kick, throw, shoot the object from the beginning, okay? And the initial height is basically where it starts, that starting height. All right, so the same equation will apply, same variables. The only difference will be it will be negative 4.9 t squared if it's in meters per second, and that's because gravity is 9.8, negative 9.8 meters a second. Okay, so how do we use this model? Well, anytime, we're going to go back to the basics. Anytime we are talking about a word problem, I have suggested sketching it out is going to be really important, just to give you an idea of what we're asking you for. So in these problems, time will always be on the x-axis, and height will always be on the y. And you've probably already seen that in the examples that we've done. So typically, you might have this. You might actually have a height starting on the ground, and so it could look like that. But this point, that vertex, is still going to be the maximum height. And typically right here is going to be when or after how long the object was in the air or when it hits the ground. So let's look at an example and building our own equations. A soccer ball is kicked from ground level with an initial velocity of 32 feet a second. Okay, so I see it's feet per second, so I'm going to use model 1. After how many seconds will the ball hit the ground? Okay, so I'm going to take my model, h of t equals negative 16 t squared plus v sub 0 t plus h sub 0. All right, so what are my unknowns? My unknowns are going to be v sub 0 and h sub 0. So I need to find those two things from the equation or from the word problem. All right, so its initial velocity is 32 feet a second, so that's 32. And my initial height, well, it says it's kicked from ground level, so my initial height is 0. So my equation would be h of t equals negative 16 t squared plus 32t. Okay, so I don't have to put in anything in for 0. Okay, so my graph actually looks like that, right? Time, height. All right, and it asks, after how many seconds will the ball hit the ground? So it's looking for this point right here, which means it's looking for the x-intercepts, the zeros, right? We know that this one is 0, 0, so we just need the other one. All right, so we're going to set y equal to 0 and solve. All right, I see that it's divisible. I can simplify this equation, so I'm going to divide everything by negative 16. I always want to simplify if possible. So t squared minus 2t equals 0. Remember not to ever divide by a variable because you can't throw out that it would throw out an answer. Now this is that really special factor pattern, right? It's just GCF factoring. So I'm going to take out a t. I'm going to be left with t minus 2 equals 0. And then I'm going to use the zero product property. So t equals 0 and t minus 2 equals 0. So t equals 2. So that actually has to be my answer. After how many seconds will the ball hit the ground? 2 seconds. And there you go. All right, let's look at one more. Marilyn hit a golf ball on the ground with her driver. Use the general function for projectile to write a function that shows the height in feet of her golf ball as a function of time. Okay, so we normally call these projectile motion or vertical motion problems. Another way to refer to them. And we want the height as a function of time, okay? So height is my y again, and time is my x. The ball was hit with an initial velocity of 100 feet per second, and she hit it from the ground. All right, so we're going to plug that right in. H of t equals negative 16 t squared again, because it's in feet per second, plus 100t. And I don't have to put in my y-intercept because it was hit from the ground. How long will Marilyn's ball stay in the air? Again, quick sketch. Started at 0, it went to here, so I'm looking for this x-intercept since I already have the other one. All right, so I'm going to set the function equal to 0. And let's see, I'm going to probably divide here by negative 4. To simplify, because I always want it in the simplest form as possible, and I like it when t squared is positive. So that's going to give me 4t minus 25t equals 0. All right, so I'm going to factor out a t. It's going to leave me with 4t minus 25 equals 0. And so t equals 0, and t equals 25 fourths. All right, and so after how long? About, what would that be? That would be 6.25 seconds. Okay, I just want to point out one thing too, 6.25 seconds. If this is 0, and this is 6.25 seconds, I know the x coordinate of the vertex. It's going to be halfway, right? So it would just be the average of that. So it would be 6.25 divided by 2, whatever that works out to be. So I want you to think about that when you're looking at those graphs, okay? All right, guys, that's it for now. You can go on to video 2 if you're ready for it. Have a good day.